Good morning, Precalculus students. Today we will be reviewing quadratic functions. We should be able to go through this quickly as we have done this already in the past. This should just be a review. So a quadratic function is a function whose highest variable exponent is 2, so the degree is 2, and there you see the general form of it. F of x equals ax squared plus bx plus c. A, b, and c are real numbers, and a does not equal 0. Because if a equals 0, this term would no longer be here, and we would just have a linear function. So here's a little example for us. Find the set of ordered pairs described by the quadratic function rule. F of x equals 3x squared plus x minus 7, and the domain -3, -2, 0, 2. So all we need to do here is plug our domain into the function. So let's do f of -3, which is 3 times, we're putting it in for x, -3 squared plus -3 minus 7. And then we simplify. This is 9 times 3 is 27, plus -3 minus 7. Well, this is -10, so this equals 17. And we can go ahead and do the same thing with the next 3 elements of the domain. So there you have, it says find the set of ordered pairs. So the ordered pairs are -3, 17. -2, 3, 0, 7, and 2, 7. Moving on, we want to look at the graph of quadratic functions, and we've seen this before. A lot of times when we come across a function, we're going to make a table of x values and find their corresponding function value, y value, or in this case it's p of x. So let's plug in -3, -2, -1, 0, 1, 2, and 3, and if we need to, we could plug in some other ones. So x is -3, so -3 squared is 9. So we're just putting these into our function. P of -2, -2 squared is 4. Put in -1, squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. We can graph these points along here. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1, 2, 4, 3, 9. And now we can connect these points. See how this goes to sketch our parabola. All right, so there's our parabola. Shouldn't be that wavy. That's just my bad writing. So the domain, what x values do we have here? Well, we remember we could just collapse this whole graph on the x-axis. It would cover the whole x-axis, so this would be the real numbers. The range collapse on the y-axis, and we would see it as just y is greater than or equal to 0. the vertex here is the bottom part of the parabola, 0, 0. And the axis of symmetry in this case, in this parent function, is the y-axis, which is x equals 0. And so that is the parent function for the parabola. All other parabolas are going to be related to that. And what we're going to look at next is how they relate. So when we have a parabola, we can put it in this form right here. It's called work form or vertex form. Sometimes it's given to us in this form, and sometimes we have to complete the square to put it in that form. But let's review what these different things do. A, right here, this changes the steepness. If it's larger than 1, it will get steeper. If it's between 0 and 1, it gets less steep. And then if A is negative, it flips it, so it opens downward. H, adding something to the variable before you square it, moves it left or right, and it actually moves left if this is positive and right if it's negative. The reason that is, it's actually the value that makes this thing 0, the value of x that makes it 0. So if you had a positive 7 in here, a negative 7 would make it 0. And then K moves the parabola up if K is positive and down if K is negative. So let's take a look at this example. We want to graph this. So we're going to go ahead and put this into our vertex form. So I'll go ahead and rewrite this. Y equals 3x squared plus 12x plus 8. And we're going to practice completing the square to put this in vertex form. So if you recall, we want to factor the 3 out of the first two, or factor a common factor out of the first two. In this case, it's 3. You do not factor out the x. So we have x squared plus 4x. We're going to leave our 8 out here. Take half of 4. Half of 4 is 2, and add that squared. So we just added 4, but it's also multiplied by 3 out here. So we have to add, so actually we just added 4 times 3. We added 12, so we also have to subtract 12. And then we have our perfect square. Y equals 3. And really what this is, we're just factoring this, but it's always going to be the variable, and then what this number was, x plus 2 squared, and then minus 4. And there we have it in work form. We know the vertex is going to be moved left 2 and down 4. So left 2, down 4. This is going to be opening upward because it's positive, but it's going to be more steep. And so we can choose a couple points just to see where that's going to be, usually close to the x value of our vertex. So let's plug in -1. -1 plus 2 is 1. Squared is 1. Times 3 is 3. And then minus 4 is -1. So I'll have a point -1, -1. And since parabolas are symmetric, we have a point on the other side of the axis of symmetry in the same area. And then another thing we can do, we could plug in 0, but actually just as a reminder, when it's in the standard form, if you plug in 0, you get 0 plus 8. So when you plug in 0, you get 8. That's an easy way to find the y-intercept by plugging in 0 for x. So there's that. And then on the other side, the same thing. So you see this is steeper than our last graph. I'm going to go ahead and attempt to graph this again. Ooh. So this one's a very bad sketch of the graph, but hopefully you get the idea. It says give the domain and range. Well, in this case, the domain is still all reals for all parabolas. It's the real numbers. And then the range, Well, here we're greater than or equal to -4. And there's the graph of that. A couple other terms that go along with this. The zero of a polynomial, so we're specifically talking about quadratic functions here, but the zero, so the number r is a zero of p of x if and only if p of r equals 0. So if we plug in r into the function and get 0, then it is a zero of the polynomial. And then very closely related to that is the root of an equation. That's the number that is a solution of an equation. For quadratics, you could have 0, 1, or 2 solutions. Mentioned this, roots and zeros are closely related. The roots of the equation p of x equals 0 are the zeros of the function. So really, it's actually not even clear in either of these. This is where your graph is going to hit the x-axis, because when the y value is 0, you're hitting the x-axis. And that's why we can have 0 or 1 or 2 solutions. If you have a parabola that's just up here, it has 0 solutions. You could have a parabola that just hits the x-axis, changes direction, and goes back up. That's one solution. Or it could be a parabola that goes through the x-axis twice. So that's 2 solutions. So find the zeros of the function. Well, the zeros of this function are the values of x that make y equal 0. So we can just plug in 0 for y. And we can solve this. Well, in this case, this is nice and easy because it's factorable. We can factor out a negative x, and we're left with x plus 6. And so what values of x make this 0? Well, x either equals 0 or -6. So in that case, we could factor. Sometimes you have to use the quadratic formula. Find the maximum point in the function described. Well, the maximum point is going to be, if there is a maximum, it's at a vertex, and we can look at this one and we can automatically know this is going to be facing downward. So there is going to be a maximum. So we have f of x equals, and we're going to complete the square. So we're going to factor out the -2. So we still have x squared minus 8x. And then we bring our -2 out here. Keep this -2 out here. Complete the square. So we take half of -8, which is -4, and we square that and add it in the parentheses. We just added 16 here, but remember it's multiplied by this -2. So we just subtracted 32 because 16 and -2 is -32, so we have to add 32 over here. And that's enough to give us the maximum point. We don't have to graph it because we know that the vertex will be the maximum point. And so this is -2 x minus 4 squared plus 30. So the maximum point is the opposite of this, 4, 30. And those are the concepts from lesson 2.3.